Electromagnetic flow meters are devices that are commonly used in surgeries where there are exposed arteries. To figure out the sign of the ions in the blood, let's draw a picture so that we can use the right-hand rule to figure out what direction the magnetic forces would be that are caused by this electromagnetic flow meter. So if we have a blood vessel, I'm going to draw the blood vessel as a circle, and we can think of the blood as moving directly towards us. So any of the ions that are in the blood, any charged particles in the blood, would be moving so that their velocities are directly towards us or directly out of the screen. So a velocity vector would look something like this. The velocity is directly out of the screen. Now we have north and south magnetic poles placed on either side, so these are two different magnets, and we have a north pole and a south pole. We know that magnetic fields go from north to south, so the magnetic field lines would look something like this. So this is the magnetic field that the blood is passing through. So if we use the right-hand rule, we have to put our fingers first in the direction of the velocity. So that means directly out of the screen, with the palm facing towards that south pole magnet in the direction of the magnetic field. Then curl the fingers in the direction of the south pole magnet, and the thumb right now is pointing upwards. So upwards would be the force on the positive charges. So any positive charged ions in the blood would tend to accumulate towards the top of the blood vessel. Now let's think about the negative charges. So once again, fingers in the direction of the velocity vector out of the screen, palm facing in the direction of the magnetic field, curl the fingers in the direction of the magnetic field, but then for a negative charge we have to flip it. And so the force would be downward. And so any negative ions in the blood would accumulate towards the bottom of the artery, creating some positive charges here and some negative charges here. And this separation of positive and negative charges creates a potential difference that can be measured with a voltmeter. And the greater that potential difference, the more ions and therefore the more blood that is flowing through this artery. So if A accumulates a positive charge, so if this is electrode A is up here and it accumulates a positive charge, the sign of the ions in the blood is going to be, well, you get a positive charge up here and a negative charge down here by having positive ions or by having negative ions. So you could have both or either and get the same potential difference across this blood vessel. So both or either. And if you think about blood, blood has things like dissolved salts in it, NaCl, Na is positive, Cl is negative. So you have both in your blood. And so both either would be the response we would want to have.